Okay, we are moving on to a topic that's very similar to inverses, but now we're going to lift those restricted intervals that I talked about earlier. Okay, so no longer are we going to need the restricted intervals because we aren't going to have that -1 symbol in there, the inverse symbol, or the word arc. So when those two things are missing in your original problem, that -1 symbol or the inverse symbol, or the word arc, then you'll need to have every single answer in one period of the function, or every single answer in the unit circle. So if you look at that from 0 to 2 pi, basically is one trip around this unit circle. You need to have every answer on one trip around the unit circle. Okay? And I'll explain more about that when I get that. Okay, so we have done problems like this. This is going different, but you're needing to figure out what would theta be. That's kind of your question. So this is asking you to figure out sine at some spot on the unit circle is 1/2. Notice my original problem does not have a -1 symbol in it. It does not have the word arc in it. So I can't just give answers in the restricted interval. I need to give every single spot that that happens at. So we've done this before. Remember that sine is like your y value. So you need all the spots on the unit circle where your sine or your y value is 1/2. So here's one right here at pi over 6. And here's another one right here at 5 pi over 6. I need both answers, not just the ones in the restricted interval. So pi over 6 and 5 pi over 6. Because sine at pi over 6 is 1/2 and sine at 5 pi over 6 is 1/2. Okay, unfortunately they're not going to be all that pretty. By the way, here's the graph of the sine function. You can see that this is one period of it. From 0 to 2 pi is one period. You can see that there are two spots right here and right here where your sine value is 1/2 if I asked you to do that from the graph. Here's another function. If you remember when we did graphing, when you throw this 2 right here, what that does is it alters the period of the graph. I'm going to show you this really quickly. The red line is the normal sine curve without anything done to it. The blue line is the sine at 2 theta graph, and so basically that makes your period twice as fast. So you're going to have twice as many answers in there, okay? So I'm asking you to figure out where your sine value is 1. Usually you're not going to have a graph, but I just want you to see this. You can see that between 0 and 2 pi, there's going to be two spots where your sine value is 1, here and here. So I already can see from the graph that my answer is going to be pi over 4 and 3 pi, or 5 pi over 4. But I'm going to show you how to do that algebraically, okay? So here's what you have to do. Here's your graph. Notice you have something done to your theta. It's not just plain old theta right here. Your theta is being multiplied by 2. When that happens, and this is going to be a little bit confusing, here's what you have to do. You first of all have to figure out where is sine at normal theta 1. Okay? So sine at theta is 1. Sine theta is 1 at, if you look at your unit circle, sine is 1 right here at pi over 2. Okay, so that's the only spot on my unit circle where my sine or my y value is 1. So this happens at pi over 2. But I don't have just plain old theta in here. I have 2 theta. So then what you have to do is you have to do this. 2 theta equals, so I'm going to take this part that's in here and set that equal to the spot, pi over 2, I got that from right there, plus, and then I'll tell you why you're doing this in a minute, 2 pi k. We know that for sine, its period is 2 pi, which means my answers are going to keep repeating itself every 2 pi. I can start at pi over 4, go 2 pi all the way around the circle. I'm going to end up back at pi over 4, but then it'll be 2 pi plus pi over 4, so 2 1/4 pi will be my next answer. I can add 2 pi again. My next answer would be 4 1/4 pi. I can add 2 pi again. It would be 6 1/4 pi, and I think you get the pattern. Okay, so your answers are going to repeat every 2 pi. That's why you put this there. Now, if it's a tangent or a cotangent graph, if you remember from graphing, their normal period is pi. And so instead of putting 2 pi k back there, you would put pi k back there. And again, that's for tangent or cotangent. Okay, that's the only thing that's different. All right, now, here's my handy dandy little equation that I have. And now I need to solve this for theta. So I need to divide everything in half. Okay, and when I divide everything in half, then I will end up here. Theta equals pi over 4, or pi over 2 cut in half is pi over 4, and then 2 pi k over 2 would be pi k. Okay, so now what you're going to do is you're going to start with this answer right here. So my first answer is pi over 4. To that answer, I'm going to keep adding this number right here, k times. So I'm going to add it first once when k is 1. Then I'm going to add it twice when k is 2. Then I'm going to add it 3 times when k is 3. And I'm going to keep doing it until my answers get bigger than 2 pi. Okay? So to get the next answer, I will take, I'm going to do this actually off to the side. I will take pi over 4 plus pi. Okay? And by the way, you need common denominators. So this is going to be 4/4. And then I will get 5 pi over 4. Okay, so that will be my next answer. 5 pi over 4 is not bigger than 2 pi. If your denominator is 8, your numerator has to, or if your denominator is 4, your numerator would have to be 8 in order to get it to be 2 pi. So 5 pi over 4 is still not too big. Okay, then I'm going to take that and I'm going to add pi over 4 again. And again, I'm going to add pi again, sorry. Okay. I'm going to keep adding this number right here to my previous answer. So I'm going to add pi, which of course I'm going to need a common denominator, and then I will get 9 pi over 4. Okay, so my next answer in theory would be 9 pi over 4. Well, if your denominator is 4 and your numerator is 9, that's bigger than 2 pi, and your answers can't be bigger than 2 pi because then it's just a repeat. Pi over 4 is the same spot on the unit circle as 9 pi over 4. I don't need them both listed, so I don't want that one here. And these would be my only 2 answers, okay? Which of course we already saw on the graph, but that's how you do it algebraically. All right, here's a tangent one. Very similarly, okay? Again, I don't have just plain theta in here. Something's been done to my theta. In this case, it's been divided by 4. So the first thing that I'm going to do is I'm going to figure out where on my unit circle is tangent negative root 3. Okay, so tangent theta is negative root 3 at, and I'm going to figure this out. Okay, so tangent is negative, first of all, in quadrants 2 and quadrants 4. Okay, and tangent I know is icky, and you have to simplify it a little bit. Okay, so I'm going to go over here, and tangent, remember, is y over x. So 0 over 1 is not going to give me negative root 3. If I do 1/2, I'm right here, 1/2 over negative root 3 over 2, flip that. The 2's cancel. I get negative 1 over root 3, which simplifies to negative root 3 over 3. When you get it, that's not it either. When I do pi over 4 right here, root 2 over 2 over negative root 2 over 2 is going to give me negative 1. So that's not it, which means it must be right here at 2 pi over 3. Okay, so there's one spot at 2 pi over 3, and then of course you need the other spot because I need every spot on the unit circle where tangent is negative root 3, and so that will be down here at 5 pi over 3. Again, if you take negative root 3 over 2, or your y value, over your x value, and then you flip it, 2's cancel, you will get negative root 3. And that happens both at 5 pi over 3 and at 2 pi over 3. Okay? So I'm going to go over here at 2 pi over 3 and 5 pi over 3. Okay? Unfortunately, I can't stop there because I'm not finding just plain old theta. What it gave me in the equation was theta over 4. Something's been done to my theta. So I'm going to set that part of it right up there equal, first of all, to 2 pi over 3 plus, now this is tangent, so when it's tangent, I'm going to do pi k. Okay? There is 2 spots on the unit circle, so I get to do 2 equations. Okay? So I'm going to do one of them where I do 2 pi over 3. Notice this is pi k right here because it's tangent. Okay? Tangent and cotangent will be pi k. Everything else will be 2 pi k. Then I'm going to have another equation, theta over 4 equals this spot, 5 pi over 3. And again, it's tangent, so I will put pi k back here. Tangent's answers repeat every pi because tangent's period was pi, if I remember that from graphing. Okay? Then I need to multiply everything through by 4 to be able to solve for theta. And so that will drop, and I will get theta equals 8 pi over 3 plus 4 pi k. Okay? So in theory here, my first answer is 8 pi over 3. Well, 8 pi over 3 is bigger than 2 pi. 6 pi over 3 would be 2 pi, so 8 pi over 3 is bigger than 2 pi. I can be done right here. This is too big. Okay, over here, when I multiply through by 4, that drops, and I will get theta equals 20 pi over 3 plus 4 pi k. First answer right here, 20 pi over 3. Again, 20 pi over 3 is bigger than 2 pi. This is too big. There is no spot between 0 and 2 pi where this happens at. So your answer actually right here is no solution. Okay. All right, and you can see from your graph, you're needing to look for where tangent is negative root 3. It would be the blue graph here, and there is no spot where tangent will be negative between 0 and 2 pi. All right, another one, you guys. Okay, very similarly, and I probably will just do half of this one. Again, you're having to figure out where cosecant is negative 2. I'm just going to remind you of the little trick. Figuring out where cosecant is negative 2 is the same as figuring out where sine, notice I'm not switching what's in the parentheses. I'm not doing the reciprocal of that. But sine is the reciprocal to cosecant, and negative 1/2 is the reciprocal to negative 2. So looking for where cosecant is negative 2 is the same as looking for where sine is negative 1/2. So I'm going to first figure that out. Sine is negative 1/2 at, and I'm going to go to my unit circle over here. Sine, again, is your y value, and your sine is negative 1/2 here at 11 pi over 6, and here at 7 pi over 6. So there's two spots that happens at. So 7 pi over 6 and 11 pi over 6. Because it's not just plain old theta right here. If it was plain old theta, we could stop, and those would be our two answers, but it's not. Theta, in this case, is being multiplied by 2/3, so I have to take 2 theta over 3 equals the first spot, 7 pi over 6, plus, now it's sine, so I'm going to put 2 pi k here because my answers are going to repeat every 2 pi with sine and cosine and secant and cosecant. And then my other equation would be the same thing. 2 theta over 3 equals my other spot, which is 11 pi over 6, plus, again, 2 pi k because it's sine. All right, and now I get to solve, and I will probably just do half of this because I think you guys can handle the other half. But I will multiply by 3/2 all the way across, of course. Those will drop. And you will get theta equals, and I'll drop a 1 and a 2 here, so 7 pi over 4 plus, that's going to drop 3 pi k. Okay, so here's the first answer that you start with. The first answer would be 7 pi over 4, and you need to ask yourself, is that too big? And it's not, because 8 pi over 4 would be too big, okay, or bigger than 8 pi over 4 would be too big. Now, if you add 3 pi to a quantity, it's clearly going to be over 2 pi. So you don't even need to add this 3 pi to it, because 3 pi plus anything is going to be bigger than 2 pi. Okay, so this is your answer. All right. And by the way, your answers always have to be positive, so you don't want negative answers either. Okay? And then I think you guys can figure out the other half. You're going to do it very similarly. I'm going to show you this and look back at the graph. Except for that's not the graph I wanted. I want this one. I'm needing to figure out where cosecant is negative 2 in this interval, and there's going to be one spot, according to my unit circle, right here at 7 pi over 4. So when you do that other half back here, and you do this side over here, you should not get an answer. It should be bigger than 2 pi right from the get-go, just so you know. So you can check your answer on that if you want. All right, and we have one last one right here. Notice this is a little bit different for a couple of reasons. One of the reasons is you have this 2 in front right here. So I need to get rid of that first of all and divide by 2. Okay. And then I have this problem. Sine at 2 theta minus 70 degrees is 1/2. Okay, notice I don't have just plain old theta again. So first of all, I need to figure out where is sine 1/2. Where does that happen at? So I'm going to my unit circle, and I'm going to look for where sine is 1/2. Sine is 1/2 right here at pi over 6, and sine, or my y value, is also 1/2 over here at 5 pi over 6. So at pi over 6 and at 5 pi over 6. Okay, then I'm going to set what's in here, 2 theta minus 70 degrees equals pi over 6 plus 2 pi k. And then, of course, you'll have to do your other one. 2 theta minus 70 degrees equals 5 pi over 6 plus 2 pi k. Okay, now we have a problem. Okay, here it is. This is in degrees. These two things are in radians. So you need them all in the same units. I think it's probably easier to think in degrees. So I am going to leave the 70 degrees, and then I'm going to say pi over 6 in terms of degrees, and you can look at your unit circle and do this, is 30 degrees. And 2 pi in terms of degrees is the same as 360 degrees. Okay? So I want to solve for theta, and so I'm going to add 70 here. Notice I'm not adding 70 to the 360k because I can't add something that has a variable with something that doesn't. So that drops, and I will get 2 theta equals 100 plus 360k. Divide by 2. And I will get theta equals 50 plus 180k. Okay, so your first answer is 50. If you add 180 to that, you will get 230. If you add 180 to that, you'll get 410. So you're going to keep adding 80 or 180. Excuse me here. All right, so sorry about that. We are going to, okay, so 50 and 230 count because they are not bigger than 2 pi. And by the way, 2 pi is 360 degrees. So it can't be bigger than 360 degrees. That drops. Okay? Then you can go and do the same thing with the other half, which I think you can handle. You can solve the other half. Actually, maybe I better do this. Okay, so 2 theta minus 70 degrees. 5 pi over 6 is the same as 150. And of course, 2 pi is the same as 180k. Add 70. So 2 theta equals 210. No, 220, sorry. Plus 180k. Divide by 2. You know what? I just messed up. This should not be 180. This should be 360. Sorry. I was a step ahead of myself. Divide by 2. Theta equals 220 divided by 2 is 110. 360 divided by 2 is 180. Okay, so here's your first answer. So my first answer is 110 degrees. I will add 180 to that, so that will give me 290. Plus 180 plus 290 is going to be too big, so I can stop right there. So I actually have 4 answers to this between 0 and 2 pi. All right, there you go. That is this lesson in a nutshell.